here we assign the chip sequences to the users in such a way that the dot product of any two chip sequences is 0. So the requirement is the chip sequences have to be orthogonal to each other. Okay. And let's go through an example to see how this scheme works. So typically I'll give you a problem like this where you have two users who want to send data like 0, 1, 1, 0 and then 1, 0, 1, 0. So this is coming from S1, this is coming from S2. Okay? And they are assigned S1 and S2 are assigned chip sequences 0, 1 and 1, 1. Okay? Now if they are sending simultaneously, there will be collision, but we are trying to avoid collision by making them to kind of encode their data along with this chip sequence. Okay? And so when those two signals kind of meet, you get a kind of composite signal. And you'll see how this works. Okay? So the first requirement, first step is to check whether the chip sequences of the two users are orthogonal. Okay? Now, to do all the math, we are going to change, kind of transform the zeros to -1, and 1 will be retained as it is. So, for example, the data for the user 1, this is the original data. We are going to write it as a matrix like this: -1, 1, 1, -1, where all the zeros are changed to -1s. Okay. Similarly, for D2, 1, -1, 1, -1.
Why did we change the zeros to 1?
Because we want to do some math on matrices. We work with zeros and we do multiplication. 0 times everything equals 0. So we'll make them as -1. Okay. Now the chip sequences similarly initially are given like 0, 1 and 1, 1. So we're going to write as -1, 1 and 1, 1. Okay. So the first step is to take the dot product of these two chip sequences. So -1, 1 and 1, 1. So this is not a matrix multiplication, it's like a dot product vector multiplication. So this -1 multiplied by this one plus this one multiplied by this one. So this is -1 plus 1, which is 0. It's a term-wise multiplication. Okay? And we have to check this. If the dot, if the dot product is 0, we can proceed further. Sometimes I may give by mistake or even trick you by giving two chip sequences, this dot product will not be 0. Okay? If they are not 0, the dot product is not 0, you cannot proceed further. You can simply state that the chip sequences are not orthogonal, so you cannot proceed. So that's like a prerequisite that the product, just like this term-wise product, has to be equal to 0. Yes?
You lost me, right? When you got to the initial step, you got the C1 and C. Yeah, right there.
These are like the initial chip sequences assigned to the users, 0, 1 and 1, 1. And they're unique. Each user has to have a unique chip sequence. Okay? So, first we have to check whether the chip sequences are orthogonal. By orthogonal, what I mean is the product of the two chip sequences should be 0. Okay? And here we are doing like a vector, a dot product multiplication. Of course, we replace the zeros with -1s. have, let's say, 1, 2, 3, 4, 5, 6. What is the dimension of this matrix?
2 by 3.
2 by 3, yes. 2 rows, 3 columns. So when I say I'm going to transpose this, it means I'm going to write the rows as columns, and columns as will become rows. So I'm going to write this as 1, 2, 3, 4, 5, 6. So this is going to be the transpose of this matrix. So it's going to be a 3-row, 2-column matrix. Okay. So originally we write our check sequence as -1, 1. So this is going to be a 2 by 1 matrix. Okay. So now when you transpose this is going to become -1, 1. So this is going to be 1 by 2 matrix, 1 row, 2 column, and this is a 2 row, 1 column matrix. Okay. So number of rows and then number of columns. So you're going to multiply this matrix with the data matrix, which is -1, 1, 1, -1. So the dimensions of this matrix is what? The data matrix is of what dimension?
Is it
How many rows and columns?
2 rows?
The 2 rows here? Just 1 row, right?
1 row.
This is 1 row.
1 times 4?
Yes. 1 by 4.
Can I ask you a question?
Yes.
On that one, you got -1 and 1, and you. Okay. All right.
-1 and 1. Alright, so now again for matrix multiplication, there should be a requirement when you can multiply 2 matrices. Can anyone say when you can multiply 2 matrices? Like, can you multiply these 2 matrices? You cannot multiply any 2 matrices. There has to be some property or condition that has to be satisfied. You want to multiply 2 matrices. The number of columns in the first matrix should be equal to the number of rows in the second matrix. Then only we can multiply any 2 matrices. So for example, if you have 1, 2, 3, 4, 5, 6, this is a 2 by 3 matrix. And then let's say you have 4, 1, 2 or something. So this is a 3 by, happens to be. Let's say this is 4, 1 and this is a 2 by 1 matrix. You cannot multiply these 2 matrices because the number of columns in the first one doesn't match with the number of rows in the second one. Okay? So only if they match, let's say like this, number of columns is equal to number of rows here. The resulting product, of course you have to compute the product matrix, but the dimensions of the product matrix in this particular example will be number of